Well, good afternoon, everyone. My name is Brian Surratt, Vice President of Data Science at Capital One, and I'm happy to be here today to give you my perspective on the importance of anomaly detection in finance, some of the types of problems we face and some of the challenges that we face that might be unique to the finance industry. I'll start with a couple of caveats first, or these are my views, not necessarily those of my employer. Second, unlike all the other talks you've seen so far, I'm not going to go into any detail about specific anomaly detection methods. That last one's a real tough act to follow. Instead, I'm going to talk about practical considerations that don't tend to get a lot of attention in academic conferences. Things like the importance of having systems of defenses, using multiple anomaly detection tools, and practical considerations like keeping the algorithms up to date and enabling routine updates in production systems. Now, these may seem like pretty pedestrian issues, but I hope to convince you in my brief time today that they're hugely important for making anomaly detection actionable and effective out in the wild. All right, so with that said, anomaly detection is about data. Data flow in and out of financial institutions continuously as huge numbers of individual events, streams, and aggregations. They flow from a wide variety of data sources: transaction streams, transfers, trades, purchases, historical and third-party data, not to mention web and mobile device traffic and system logs. The list could go on and on. The modern finance industry is built on data, so much so that it's probably not a stretch to say that data are among the most important assets that financial institutions possess. So being able to identify and understand unusual changes in data is hugely important for the operations, customer experience, and profitability of financial institutions. And that probably gives us a pretty good working definition of an anomaly. An anomaly means something unusual and important has occurred in the data-generating processes of interest. Unusual in the sense that it's atypical, important in the sense that it could have a material impact on customer experiences or business outcomes. We usually assume that anomalies will be outliers compared to other data, but I'd point out that an extreme outlier that's the product of pure volatility is not intrinsically of interest unless it affects or is likely to affect business outcomes or customers in a meaningful way. So what types of anomaly detection problems are most relevant in finance? Credit card fraud is the problem that probably gets the most attention, largely because the losses associated with fraud are so high and the patterns of fraud evolve so quickly. According to a recently published report, credit and debit card fraud at US banks exceeded $8 billion in 2015, or roughly 6 cents out of every $100 spent. I'd add that card fraud can be really hard to detect. For example, fraudsters will try to mask their activities by using multiple cards for small dollar amounts across many merchants. They also change their strategies over time. This is sometimes called population drift. And these two problems, masking and population drift, tend to pop up again and again in anomaly detection. Cybersecurity is another area that gets a lot of attention. Like other institutions, banks are the target of cyber criminals who try to exploit weaknesses in computer systems to steal company and customer information that can later be used to perpetuate fraud or other criminal activities. So cyber defenses include monitoring hundreds of data sources, millions of events, terabytes of data every day. To be effective, monitoring often needs to occur in real time. So another common feature of anomaly detection problems is that they need to monitor huge volumes of data, often in real time. So card fraud and cybersecurity tend to get most of the attention, along with rogue trading, check and insurance fraud, and money laundering. But given this is a workshop about anomaly detection in finance, I need to point out another area of importance to banks, which is credit risk management. Banks are in the business of lending. They can live and die on the basis of their ability to manage their credit risk. I mentioned earlier that American banks lost around $8 billion to credit and debit card fraud. But that's just a fraction of the total credit losses that banks incur each year. Net charge-offs at banks last year were about $40 billion, which is 5 times the fraud figure I mentioned earlier. And credit's probably more cyclical than fraud. During the Great Recession, now almost 10 years ago, commercial banks in the US charged off nearly $200 billion in a single year. So it's a pretty important problem. All right, broadly speaking, there are two flavors of anomaly detection, problems where we have reliable labels and problems where we don't. As I see it, anomaly detection with labeled data can be viewed as a special class of supervised rare event modeling. For decades, academics and practitioners have advanced the science of rare event predictive modeling where we have reliable labels. If we think about anomaly detection with labeled data as a class of supervised rare event modeling, we have good tools to bring to bear on our problem. Within the supervised space, my personal view is that the biggest problem we face are related to the amount of effort needed to keep our detection defenses up to date. I mentioned two of these problems earlier, population drift and the ability to easily update deployed anomaly detection defenses. And I think these two problems are related. Focusing first on population drift, it's actually pretty common to see structural changes in data generating processes over time. Sometimes these changes stem from changes in target behaviors that occur naturally over time. Sometimes they stem from something sudden, like when a vendor or an upstream system introduces an error or changes data definitions without warning. Delays in being able to identify population drift can be extremely costly. The longer a data change or a fraud ring or a cyber intruder goes undetected, the longer the delay before a change in consumer behavior or a turning point in the credit cycle can be identified, the larger will be the impact. So it's not enough to have good algorithms. We need to be able to update and deploy them quickly in response to evolving patterns. Unfortunately, the practical reality is that algorithms can generally be updated pretty quickly in a development environment, but getting them updated in production systems easily is a much more common problem than many realize. So since we're at KDD, I want to point out some good news here for data scientists. You're all pretty well positioned to help solve these problems. I think data scientists are unique in that they can bring both algorithmic expertise, including a deep understanding of the statistical theory behind the algorithms we're talking about today, as well as expertise developing automated software-like deployment pipelines that'll make it easier to implement updated defenses more quickly. I really can't overemphasize how important I think that is. There's a really strong market for data scientists who can both develop better algorithms and automate or self-manage deployment of updated algorithms into production systems. All right, now let's shift out of supervised problems. The area of anomaly detection that intrigues me the most is actually in the unsupervised space, where we don't have definitive labels for the rare outcomes of interest. Unsupervised anomaly detection is a really hard problem. But there are lots of problems in finance where we want to identify unlabeled anomalous behavior. We need to supplement our supervised methods with unsupervised techniques to detect fraud, cyber attacks, insider trading, money laundering, and credit risk. I've spent much of my career working with predictive risk models, so much of what I'm about to say relates most directly to models supported by predictive, multivariate predictive modeling. But the core point I want to make is that they're generally applicable to other kinds of anomaly detection problems. So risk models are typically based on labeled rare event data, and they'd fall into the supervised category. But there's tremendous value in being able to detect changes in data generating processes that support these models before fraud or defaults or other adverse outcomes can have too large of an impact. We do this through monitoring and other early risk detection processes, and this is an absolutely important, essential part of operating a well-managed business. Risk models are often based on thousands of data elements and hundreds of data features. These data change significantly all the time, sometimes due to innocuous things like changes in the data reporting practices, sometimes due to reporting errors, sometimes due to customer behavioral changes or secular changes in the economy. Being able to identify earlier when important aspects of the data generating processes have changed means they can be identified before they can have a large effect on customer experiences or business outcomes. Models can be updated, business processes can be fixed or modified. This type of monitoring is essentially an unsupervised problem where anomaly detection methods can be extremely valuable. So I'm nearing the end of my time, and I think I'm all that stands between you and a break. So I'll just close with a couple of points. Just to recap. First, Although they tend to get the headlines, anomaly detection has broad applicability in finance beyond fraud and cybersecurity. Anomaly detection can make banks more effective in their anti-money laundering efforts, their credit risk management, detecting rogue or insider trading, and even enhancing customer interactions with externally facing mobile and internet applications. The second point I'll make is that it's not enough to have good algorithms. We need to be able to update and deploy them quickly and easily in response to evolving patterns. And while this may seem like a trivial point, it's unfortunately an all too common problem. Creating a process that allows for routine updates to algorithms and the means to connect them with production systems is an absolutely essential part of making the algorithms we're here talking about today more effective and actionable out in the wild. My last point is I don't believe we'll find a single magic bullet. The best anomaly detection defenses will have many layers. Unsupervised anomaly detection can be used to detect emerging risks before adverse outcomes can have too large of an impact. Supervised methods can flag anomalies consistent with past experiences. And I didn't talk about this, but human investigators will still be needed to evaluate the individual anomalies that pop up. The wide range of algorithms that we have should not be viewed as a one or the other choice, but a menu from which to construct a robust multi-layered system of detection defenses. So I think I'm out of time. Thank you for coming to our workshop.